This is the Amp Hour Podcast, released September 24th, 2025. Episode 703. Building Wafer Space with Tim Ansell. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And hello, I'm Tim from Wafer Space.
Hey, welcome back, Tim. How you doing?
Good. It's been a while since we've last talked on the Amp Hour.
I know. Yeah, five years or so. Time flies, huh?
Yes, it definitely does. The last time we were talking about open source silicon space and the fact that I was at Google at the time and we'd just released a open source PDK that was actually manufacturable.
Yes. Remind people what a PDK is.
PDK stands for Process Development Kit, and it's basically like the fundamental information you need to create silicon chips or integrated circuits.
Yeah, and that was part of your broader push at Google to just do open source silicon, and that really, between that and then like all the OpenLane that was part of, the CIA did some of that stuff, no, DARPA, I don't know who was doing OpenLane, but Andreas was on the show talking about it at one point, but...
Yes, Andreas Olsson was part of DARPA, and they did two programs called POSH and IDEA, and out of that project came a place and route tool, which is kind of like a back-end compiler for IC design called Open Road. And that was then integrated into a complete end-to-end suite that basically let you turn the description for chips, the RTL, into GDS, which is kind of like, if you're a PCB person, the Gerbers of the chip design world, called OpenLane. So, and that was done by a company called eFabless under contract from Google. Cool.
That is a lot of words there, but I think actually if people listen, some of those should sound familiar, I think. And this is all, like you were pretty fundamental in moving a lot of this open source silicon stuff forward. So it's been good, except we've had a roadblock, not a roadblock, but a setback, I think, a couple months, years ago. When did that happen?
At the beginning of this year.
So tell us what happened there.
eFabless was a VC-backed startup, and sadly, some investor disagreements meant that at the beginning of the year, that company shut down. And so eFabless was responsible for making it possible to do the actual manufacturing. They were the equivalent to, say, Osh Park in the PCB world, or if you're too young to remember the world before Osh Park, kind of like PCBWay or JLC PCB or those kind of newer pooling services. eFabless was doing that with a company called Skywater in Minnesota who did the actual manufacturing.
Yeah, that's what's interesting. So we had Matt Venn back on the show like a year ago at this point. And Matt subdivided down one of those, but that subdivided down like a lot of wafers as well, right? So it's like a fraction of a fraction of a fraction sort of thing, right?
Yeah. So the way I kind of like to think about it is, doing an actual run to make silicon wafers costs, 200 to 300K, at least with the Sky 130 process. And so if you divide that by 40, which what eFabless was doing, is how you get down to about the 10K price. And then Matt then would then take that 10K price and divide it even further. So that is how he gets to the $200 price, which allows for $200. You can basically get your own circuit design manufactured, and you get back a PCB board with your chip mounted on it and ready to go. So by far, Tiny Tapeout, which is the program Matt Venn runs that does this, is by far the cheapest way to create your own silicon chip. And so like one of the things that I think people don't really realize is that kind of at this price point, it no longer matters whether or not you're doing something useful or whether you really have any goals in mind, you can just try it and see if you like it. A comparison I often bring up when people ask me, what use is this?
Don't ask that. No questions, please. We're not taking questions from the audience right now.
Nobody asks whether Hello World is useful, right?
That's right.
Like,
yeah, that's a good
it's
way.
a first step in learning whether this is something you want to do, learning how things work, all these type of things, right? Like, and it takes a lot of work to get to a point when you're a coder before you're doing, programs that are actually useful.
Yeah.
This is kind of same in Silicon, and Tiny Tapeout really gives you the ability to do that and see whether you like it for, a very low cost price. It's probably cheaper than a Lego kit.
Yeah, especially those things are getting up there, like the Death Star and like all the ones that you can build that are massive, right? So the VC thing, that didn't work out with eFabless, that sucks. But what about like just you've had this view of the industry, obviously you've been within the industry pushing for a lot of this stuff as well. Aside from like the fact that the eFabless is no longer with us, companies are still building this stuff, past the tiny tape out stage, the try it out, the hello world of silicon. Now you're moving into the Osh Park, the PCB way, more eFabless, and what we'll be talking about here, your new venture. Like, are companies actually doing this? And then what are they building with it?
So I guess one of the big things with open source is it's hard to know exactly what people are doing because unlike with, proprietary solutions, you don't have to ask for permission, right? Like anybody can just decide to do things. But recently, I think maybe it was last weekend, there was ORConf that was actually hosted in Matt Venn's hometown of Valencia. The recordings from those talks are all up. And there were numerous groups there talking about doing open source commercial projects, including a group that maybe I'd recommend you want to get on Ampower, Thomas, who's from Spherical, who is doing basically chips that go into space using completely open source tools to develop basically new types of power supplies for all the type of things that go into space, which seems like a pretty cool topic to discuss with him about.
You always give a good list, like people are going to be hearing like, and this guest was recommended by Tim. Tim knows a lot of people, and it's very helpful for filling out the Amp Hour guest list. So I always appreciate that. Thank you.
One of the things that I think is really helpful in the community is like just sharing that there are other people out there doing cool things. I would have never got into this space if I hadn't found out from various other people all the cool things that were happening. I think it's kind of a duty of people to kind of share other cool work that's going on.
Yeah, I totally agree. And actually, I've stepped away from Twitter/X and just a lot of social media generally. And it's just, that was a lot of my source of news and, how I discovered stuff like that. So it's like, yeah, you have to, kind of depends on your sources and where you find this stuff. Hopefully people are using the Amp Hour like that. So other ways like that. Are there other news sources that you use? I mean, social maybe these days?
I do think that the loss of Twitter was a bit of a setback. There's a lot of stuff happening on LinkedIn, but it's a little bit different because of job aspect that LinkedIn has always pushed. LinkedIn seems to be where a lot of Silicon people are hanging out. There's obviously, Blue Sky and Mastodon and Threads as well. But the volume just isn't as high as it was when Twitter was at its heyday. So sadly, I don't have much more than that. There's a lot of stuff happening on Discord, but that's not really a news source, right? It's more like a chat channel.
Kind of flies by too. Kind of if you miss it sort of thing, which is...
Yes.
Well, and if people may have missed your new project, which you're here to talk about, and I definitely want to hear about. So what is your new thing?
Coming back to kind of the eFabless collapse. At the time, eFabless was pretty much the only way, if you're doing open source silicon, that you could get your stuff manufactured in small quantities at a reasonable price. One of the things, though, that I was somewhat frustrated with eFabless was that at Google, I had released 2 open source PDKs. There was the Sky 130 PDK, which is 130 nanometer all-inclusive type process technology that was manufactured in the US at Skywater in Minnesota. They're a fairly small foundry, which makes it a rather expensive technology. But we also partnered with a company called Global Foundries to release the GF180 MCU PDK. And Global Foundries is one of the quite big silicon producers in the world. I think they're maybe in the top 5. I was always trying to push them to do a equivalent program for this technology, but they never did. While they existed, it didn't seem right to somewhat create a competitor to eFabless, but with them kind of disappearing, I kind of decided, well, maybe it was time to make that a reality. And so I started a new company based in Singapore to basically provide the community access to the GF180 MCU PDK manufacturing at a much lower cost, because that's a much cheaper technology than the Sky 130. And that's manufactured by Global Foundries in Singapore.
That is awesome. Just to clarify on the Global Foundries thing. So your work at Google had kind of opened up the Global Foundries thing, but then you're just saying eFoundries wasn't picking up on it kind of thing? Is that the idea? As like a commercial offering?
As part of the Google program, we did a couple of free shuttles where we had over 80 different people tape out designs and get chips back. But the problem was that none of those people could really continue to do any development because there was no cheap way to get more chips made. And, eFabless, obviously, I worked very closely with them, and I'm still good friends with a lot of people who were at eFabless, but they very much decided they wanted to focus on the Sky 130 process technology, which, as I said, is a good technology if you need the features or you need your chip manufacturing happening in the US. But, that drives the cost up. And I'm a big believer that the cost is proportional to the ability for people to do interesting stuff. So the more we can drive the cost down, the more people will be able to do cool and exciting projects using the technology. And so that was kind of my focus with doing Wafer Space. It's very much based on how Osh Park operated in the early stage, that it's basically you give us a design and we manufacture it. There's no kind of support or any of those type of things offered. That's all done by the community. But in turn, it means the price is as cheap as we can offer it. And so what I'm kind of offering at the moment is for $7,000 US, you get 1,000 chips back.
Yeah, that's not a small amount of chips. What is the equivalent at Skywater? Like, or I guess the eFabless of yesteryear, what were they doing? So it was like 10,000 for a run, but how many chips would you get out of it, sort of thing?
Somewhere between 150 and 200 chips back. And I think that's the big difference that I'm trying to do here, is that 1,000 chips is enough that you can actually think of it as low volume production, not as a prototyping service, right? And so like with 1,000 chips, get 1,000 chips back, you do your first prototype PCB run and, mount 100 chips on that, and it doesn't work because your first version never works. And so you do your second one, you get another 100 and that works. And then you've still got 500 left for the product that you ship to your customer. And, 500 units sold is definitely a very good start for a small product. And, at $7 a chip means these products owe $100 products based on the, 3 times BOM cost means you can have kind of like a $30 to $40 BOM. And of that, $7 being a custom silicon seems like that could work.
That is very viable. I work for industrial customers that were like, yeah, we're shipping like 100 units a year, maybe. And if there's a high value arena that they want to lock down a little bit more, really customize, make it super power efficient, that's where this really starts to come in, I feel like.
Yep. And, that's kind of what I think is interesting about this approach is, as well, it works for things like Matt Venn's project. He charges $200 in many cases because if everybody got a board back, he wouldn't have enough chips. Whereas with the Wafer space offering, and a couple of months ago, Matt Venn announced that he was porting Tiny Tapeout to the GF180 MCU technology, which is what Wafer space is offering. He could probably offer an even cheaper option than he does today because he has plenty of chips, right? And maybe even offer you getting back more than one. Today, everybody only gets one back, which means it's good for like experimentation. But if you ever wanted to like build a small product out of it, you know, maybe you only want 5 or something, or even just one to give your friend, right?
I was just thinking when I smoked the first one, because I always seem to, you know what I mean? Like, you don't have to be as delicate just to move innovation forward, right? Just to speed things up and allow people to run a little looser and closer to the rails.
Yeah, and I think that's a big thing here is that like, and that's why it's common for industry versions of this to give you maybe 50 chips back at total. And they tend to also have quite strict requirements that you're not allowed to sell them or any of these type of things because they're running these programs at a loss. The reason they're running these programs at a loss is because they just don't have enough people doing chip design. And I think the thing that the open source stuff has really shown is that the reason people aren't doing chip design isn't because nobody wants to do chip design. It's because there are very large barriers to entry and huge costs involved. And so, like, the open source silicon, I think, has really changed that. I believe Tiny Tapeout has done almost 3,000 projects through Tiny Tapeout, and every run seems to have even more projects than it did last time. And so I think this is really showing that when you open it up and really allow people to experiment and give a cheap way to do learning, there is the ability for people to create enough designs to make this a industry that doesn't have to lose money.
Right, exactly. I mean, I feel like you guys should also start a recruiting arm. You and Matt should start like the Wafer Space / Tiny Tapeout graduate pool of people who know how to actually build chips good. Because the industry needs people like that as well.
Yep, and that was one of the things back when I was at Google was that when talking to the government, they were very clear that they needed 100,000 new designers over the next 10 years, which is, 10,000 students a year. Yet all those programs they were offering were only maxing out at, 1,000 people a year. Because if I was an employer, I would want my silicon designer to have done some type of tape out as part of their learning. And there was, or in many ways still is, no way to get 10,000 people every year to do a tape out. I really think this, if they're right, and I actually think they're wrong in that I think they've underestimated how many people are needed. I think places like Tiny Tapeout and what I'm doing with Wafer Space have shown to be really the only way to scale up the number of people entering this industry. And I think one of the things that I had in an early day of Google was kind of like a graph which showed that Google's hiring rate of hardware designers. And if you extrapolated it, there was kind of like a point where in something like 2030, Google would have had to hire every single hardware engineer on the planet.
Well, obviously AI is going to do it, Tim. Come on. What are you talking about? I don't know
all these AI run on chips, right? So that's actually one of the things that has been an advantage is that thanks to AI, there is a lot more interest in chips. And like those people are working on some of the most advanced technologies on the planet. But there's this kind of cruel thing that's kind of happened is that all the senior executives learnt on very easy technologies. But today, when a person does their first tape out, it can frequently be on something like a 12 nanometer technology in their PhD program. That being the first time you've ever done a tape out.
$10 million masks and stuff like that, right? It's just like, oh my God.
Yep, you get one chance at it. And, people screw up all the time. It's part of being a human. And so that's kind of a bad way the industry is. Whereas like Tiny Tapeout, if you screw up, it's only $200, right? And hopefully in the future, it'll be even less than that.
That's like a textbook cost, right? That's basically one textbook.
Yep. Being able to cut your teeth on these older process technologies, which also, are much more well behaved, right? When you starting to get to these advanced technologies, physics starts to go a bit wonky. You have to worry a lot more about quantum effects and all these other stuff. On these older technologies, things are much easier. It makes sense to start there.
Well, let's talk about that. So I have your crowd supply page up right now, which is also linked at buy.wafer.space. And we'll link all of this stuff in the show notes, of course. But let's talk about the layers, the size, the capabilities, especially compared to the 130. Because you said there's some stuff in 130 that people don't need. Maybe let's just start with, okay, so there's a 3.8 by 5 millimeter design envelope area. And you have these 5 layers. It's a 180 nanometer process. What is the benchmark for what you could put on there maybe at the high end of like really tightly packed kind of design?
I've always struggled to answer this question because there's a big difference, I think, between what industry says you can put in this space and what the open source community is showing you can put in this space. The example I kind of give is there's this developer who has created his own Linux-capable SoC that was taped out on Tiny Tapeout. He did that entirely by himself, not as a full-time job, as a part-time job. He is an embedded software developer by trade, I believe. I've never met the guy in person. He developed this and then taped it out on Tiny Tapeout. Industry would have said that you don't use 130 nanometer process technology to do a Linux SOC. You can't fit it in something like Tiny Tapeout. Tiny Tapeout is way too small to fit something like Linux capable processor. But I have a Tiny Tapeout board with his design on it and it boots Linux. And, the great thing about it, him being an embedded, software person is like, I want this to boot mainstream upstream Linux kernel. You don't need some board support package or anything. It just boots, you download Linux from kernel.org and compile it and it boots. Wow. And so this was all done by one person as well who'd never done, it wasn't like he was previously a chip designer or something. I forget when he started, but less than 5 years ago, he had never done any type of chip design or anything like this. And now he's doing, full Linux capable SoCs through Tiny Tapeout. If you think about it, the 20 millimeters squared is way more space than you get with Tiny Tapeout, because Tiny Tapeout takes that space and divides it by about 100. So you could definitely do something like a Linux capable MCU.
Yeah, I think one of the things we've talked about when Matt was on the show was just like limitations are usually going to be like onboard SRAM. You're going to go off chip for a lot of this stuff because you're just not going to have, making a microcontroller versus a microprocessor, that sort of thing. You're going to pack in like memory units, things like that.
Yep. And I think that's mainly a performance question because, if you're willing to go off chip, then you can have plenty of SRAM through things like the SPI SRAM that things like the Espressif 32 have made really popular. And that's how he did the Linux thing, is that the main memory is stored in a SPI SRAM, which, is a little bit slow, probably much slower than, say, using a DDR memory interface, but it definitely works. And so I think that's kind of the other thing to think about is what do you actually need to do your project? I think the other thing is we know if you move something from software into hardware, it can get significantly more efficient. Maybe you don't need that gigahertz CPU if the thing's dedicated hardware running instead of it being all in software. And, that was something that I kind of learnt the FOMU project, which we talked about previously, was that the FOMU has a little soft RISC-V core by default. And I like to say it's how I trick software engineers into becoming hardware people, because you can start by programming that RISC-V CPU with embedded C or embedded Rust or even MicroPython, but it's a bit slow, only runs at about 20 megahertz. Us software engineers are used to hundreds of megahertz these days and things like this. But you can do things because it's a soft CPU is if you need to read 8 bits from 8 different registers, you could rearrange that so it's only one read. So instead of it being, 16 instructions of like a read and then an XOR to get out the bits and all these type of things, it can just be in the right place. So that's like a single register read. That can significantly improve your performance by 8x. And so all of a sudden that 20 megahertz processor is much more powerful than you thought it was. And you kind of show software engineers this trick, and then you go away and you come back and they've developed this whole system, this massive SoC with all this hardware acceleration. And you're like, well, I guess you're a hardware engineer now and you never knew about it. And so then obviously the next step after that is you can convert that into an actual chip now. It doesn't have to stay on an FPGA. I definitely still think FPGAs are a great way to get started. If you want to go further, you can, and it's no longer as expensive, right? At $7 a chip, that's not much more expensive than, say, an FPGA. And so all of a sudden, you can also do things that you can't do on FPGAs, like analog circuits and other things like that.
What about how these things are like actually delivered back to people? You're going to be designing these chips. Actually, I was looking at the timeline, which is tighter than I would have guessed as well. So you take final submission date, December 3rd. You expect these to be delivered to customers by March 15th. What would people be getting in the mail on March 15th?
So by default, they'll get back bare silicon die. So that is useful if you want to do more processing on the die or you have special requirements. I'm also working with a number of those PCB manufacturing houses to allow me to ship those die directly to those places to be assembled onto your board using a technology called chip-on-board wire bonding. Instead of getting back a bare die, which most people know what to do with, you can get back a PCB with your chip already mounted on it, ready to go. And that will all be done through these board manufacturing houses like PCBWay, JLC, PCB, Seed Studio, all that type of thing. And so that offers you a lot more flexibility.
Are they regularly doing chip on board?
It's not a standard offering as of today, but that's mainly because people don't normally have a source of chips that aren't already packaged. And so it hasn't made sense for them to offer something that nobody can use. With things like Wafer Space, the hope is that now there'll actually be customers for this. It makes sense for them to offer that. And we're still working through what that flow looks like. And the reason I'm doing this is because silicon is $7, but it costs you $7 more to do the packaging of the chip. That doesn't make sense to me. You can choose to get your die back and work with a packaging house if you want. You're perfectly welcome to do that. But this chip on board packaging means the packaging can be, sub $2. And it also means if you want to, you could turn your die into something like a little dip package, right? Your PCB doesn't have to be, a full product. It could be something like one of the ESP, 32 style modules. Or it could be a breadboard compatible, dip pin chip. And another group that we're working with is the group that's trying to make a replacement for the Z80. Obviously, those chips are all in dip packages. And so they want, a design that they can just drop into existing designs. And so they will probably be using a PCB that makes it look like a dip package.
Yeah, at a certain point, it's just a little bit of... polyamide could be also epoxy, right? It is kind of an epoxy type substance anyways, I think, right? Make your own mold, drop the thing in, and there you go.
Yep, so I'm no expert on epoxies or chemistry, but I'm certain you could probably encapsulate them like that if you wanted even the thing to look like a dip package.
Yeah. And you're specifically not going towards like a packaging house that would put it into a standard QFN or anything like that?
The big problem is packaging houses don't want to deal with this size of volume. And even when they do, they charge exorbitant prices, right? As I said, $7 per chip is probably fairly cheap from a packaging house, especially at the volume that we're kind of dealing with. And so, plus their turnaround time is terrible.
I am actually surprised that with all the, the rah-rah, US chip making stuff, that nobody has even, as far as I know, I mean, I could be very wrong about this, I have not heard of anyone trying to do US based packaging. Just like there's no motion in that. I think every time I've asked someone about it, they're like, nah, I don't know anything. It's always going to Malaysia or Philippines or Vietnam or, wherever. It's super high volume. But I just feel like with all the US chip stuff going on, that someone would be like, yeah, the US is going to need this too. Like, okay, fine.
So there are people doing that. I know Skywater has a play in that space. They're doing advanced packaging. And what we need is like stupid packaging that is super cheap. And that's just not an area that groups like the CHIPS Act is really focused on. They're focused on, super high-end chips and these type of things. There's probably places in China that would do it for the type of cost and volume that would make sense. But, again, they generally aren't offering it outside of China. I'm hoping some of that will change, though, as things like Wafer Space start having people have more bare die looking for bonding services, right? Like, one of the things that I would probably say is that there's probably less than 10,000 people out there looking for packaging services today. And, every run I do is 40 new people who potentially need packaging services, right? And these 40 people each need 1,000 parts packaged. That is 40,000 new parts that need to be packaged. And so the hope is there'll be some of an ecosystem built up around this. But until that day, going with an ecosystem that is already, I think, thriving, which is the PCB ecosystem, makes sense to me.
Yeah. And just to be clear on the PCB one as well, is that like the black blob that people would see on so like when Dave does teardown and there's like a black blob, epoxy blob that's on the board, that's often chip to PCB kind of style of bonding?
Yep, that's exactly that type of bonding. The Time Tape Out team actually has a video and a blog post about their first experiment doing that. There's some demonstration of that working already. We just want to make that a regular option that is available. And this is also like why I want to get back people bare die, is that they can then choose what they want to do here, whether they want to go with an expensive packaging house, whether they want to use a PCB house, or, wire bonders aren't that expensive. A secondhand wire bonder on eBay can be a couple of $1,000. And so if you want to just do it yourself, maybe that's what you want to do.
What is it? Have you done that? I've never considered it. Obviously, there's not a lot of options out there for me, but like how can people do it?
I know people who have wire bonders. The general experience is being that they're fairly grumpy machines. This could be, again, though, that's the type of thing that if you don't use it frequently, it tends to be grumpy. But if you use it every day, it tends to be really fine. I don't know. But like the idea is that this gives people options. As I said, kind of people having bare die to even like practice on or use these type of things was extremely rare. It definitely hoping that that will change. I'm hoping that people in the community will be like, oh yeah, if you get these wire bonders and use these settings, it will work. Because that also gives you a lot of options. Like if you want to iterate on how your form factor is, like a packaging house will easily take you 3 months to get stuff back from them. And, a PCB manufacturer will get you back stuff in 3 days these days, right? Like this is a much faster iteration speed if you're doing that.
As you're saying this stuff, what I'm really thinking is Tim says wire bonders are a couple thousand on eBay, but I would say there are a couple thousand on eBay right now. And if this becomes a thing, there's going to be a hot market for wire bonder, like used wire bonder machines, I bet.
Maybe. I mean, even new, they're not that expensive.
Oh, really? Okay. I just always assumed it was like this really complex process.
Wire bonding, has been around since the 1980s-ish, I think. It's a fairly well-known technology. The high-end machines that, can wire bond 1,000 chips a second and those type of things are obviously significantly more complicated. But I think the low volume stuff has still been around for a long time. Again, not that complicated a technology compared to anything else in the semiconductor world, right?
It's interesting. It's interesting that that's a thing that's needed still, you know?
Yeah, I think it's, again, one of these things that the ecosystem isn't there because of people just don't regularly get this type of part that needs it.
Let's talk a little bit about logistics. So first off, everybody should go sign up on the crowd supply page to get notified, because there is as far as I understand crowd supply, you need to get like 200 signups before it goes live, right?
Yeah, once it goes live, which should be pretty shortly, you'll be able to purchase the $7,000 slot or the $8,500 slot, which includes the wire bonding. Or if you want a full wafer, we'll also be offering full wafers for $2,000. If you just want a wafer, either because you want to do some more post-processing or because you want a cool-looking thing and you've got a disposable income, then sure, go and buy one. Yeah, that should be easy to do. I think we've already got the number of signups needed there. It's just waiting on a few things before we can get that live. I'm guessing by the time this podcast comes out, the buy links will already be there.
Yeah, I mean, it's not a small amount, but again, if you're someone who's like looking forward, or if they're, previously had been going eFabless, it feels like that seems kind of no-brainer,
Yeah, and I think the important thing is that the more people who do this, the cheaper it will get. And so, I'm not doing this because interested in making a lot of money or any of these type of things. I'm doing this because I think it's important for people to be able to actually make the designs they have. And so if we get more people doing it, then that price could definitely go down substantially. Because if you think about it, as I said, it's, a rather large number divided by another number. If that other number is, the divided number gets bigger, the actual price goes down. And I think that's also, an important thing to think about is one of the things I give, do you know First Robotics?
Yeah, of course.
The high school thing, to be a competitive team in First, my understanding is you need about $10,000. If we had, we were about 25% of the size of First Robotics, I would need to do one of these every week. At that kind of volume, I'm sure the price would be substantially lower. You're talking more like $2,000 to $3,000 per slot instead of the $7,000 slot. And the kind of other statistic I give is, if 50% of high schools in the US submitting one design a year, so that's not like a class thing, that's like an after-school club type thing. If they were submitting one a year, I would need to run one of these MPWs effectively every working day of the year. And at that point, 30% of the global mask manufacturing capacity would be dedicated just to my projects.
And then that would drop in cost too, I'm sure, because then it would also, the volume goes up, cost comes down,
Yep. And, that's just the US. That doesn't include anybody else in the world. I don't think we're going to get to that anytime soon, but I definitely think the capacity is there in the same way that people are starting to learn programming and AI in high school. Maybe chip design can be another thing that a percentage of kids in every school is interested in doing. And again, I'm not talking about necessarily it being a required course of that everybody does. I'm talking about, a club that, 5 to 10 kids at that school want to do something using, in many ways, which is the human's most magical technology we've ever invented.
Making sand talk magic, right?
Yes. I kind of like to say that we hit rocks with lightning and make them think, right? Like, it's pretty cool. The type of things happening in semiconductor industry are definitely on the same technology level as things like going to space and these type of stuff, right? Like, as humanity's crowning achievements, and the fact that it's kind of all locked up behind, you have to be a billion-dollar company is sad, right? Like, it should be something that everybody has access to and can do and use and have fun with.
So you mentioned like the after school club, that sort of thing. So what is the latest and greatest on actually like building a design? So is it just Verilog and that sort of thing? Is it Magic? What are the tools, the open source tools of the trade these days?
If you've never done it before, Tiny Tapeout has developed a bunch of click and drag type tools. I like to say that anyone could get started with a couple of hours on the weekend and get to the stage where they could submit a Tiny Tapeout design. They've had primary school kids do this.
The one that Matt always whispers, is that the one?
I think there's plenty of examples. I was attending a conference or like an event called Open Source recently, and I had a little booth there that a friend, John Master, was running. Randomly, a person came up, like this young kid came up, and he had done a tape out on using Tiny Tapeout, and he wasn't in high school yet. I have no idea who he is. This kind of randomly was enough that, a person turned up who had done this. And so I definitely think anybody can get started with that flow and see if they like it. There's no shame in it being not your cup of tea. Like, there's plenty of things I don't like, that you probably like. So give it a go and see if it's something you find fun. After that, there is things like Verilog and VHDL that you can go to, which is much more coding style. If you're kind of a software background, things like Verilog are probably going to be very familiar. And then if you're more like a PCB designer background, are very into like the drawing of things, that's where you get kind of into more analog circuit design with things like K-Layout and Magic, as you mentioned. That's kind of much more drawing shapes on a thing, just like in many ways drawing shapes on PCBs and that type of stuff.
When Matt was on, we talked about kind of the parallels to like a KiCad or something like it, right? It's just like it does all kind of line up. And obviously the geometries are significantly different, but at the end of the day, it's like shapes on a screen that eventually becomes shapes on a planar surface. And then, you have to learn a little bit more about implant depths and stuff if you're doing really, really analog-y things, but most people will not be doing that, I imagine.
Yep, there's these things called standard cells, which are like your AND gates and your OR gates and all those type of things. They basically created a KiCad library of those parts. So you can design in the schematic editor effectively your digital circuit. And so I thought that was pretty cool and fun. And I definitely think there is a bunch of stuff where, for example, a design, like to do the chip on board stuff, you need to design a PCB. So some more integration between the ASIC design tools and the PCB design tools could open up a lot of more opportunities in custom optimization, because you don't end up with that thing where, the pin you want to use is on the wrong side of the chip, right? Like, I'm sure we've all gone like, screw it, I'll get a higher number of layers in my PCBs because I just can't route this circuit any other way. Well, maybe if the chip had been designed slightly differently, you wouldn't have to do that. And so, I think there's some interesting things that could happen there. And because it's all open source, there's no problem for people doing that. Somebody could try and design a silicon circuit in KiCad. As you said, it's really just shapes. I think it'll be a bit crazy, but I wouldn't stop you. If you submit something that is DRC clean, I'll manufacture it.
I can imagine like a case where like someone goes from like Eric Schlepfer's like Monster 6502. That's basically like just a blown up version of a 6502 in actual transistor form. And then so you could take that, replace it with standard cells, shrink it down, shrink it down, shrink it down. And then eventually, you might not want to pay to have a 6502 and you could buy one, but you could also add your own stuff in there and that sort of thing.
I think we've seen that things like OshPark allow people to do things that, are just cool, like PCB artwork. These PCBs that are like pieces of art.
Every one of my designs, Tim, is a piece of art.
Fair enough. You could do that in silicon if you want. If you have the funds, maybe you've got a grant and want to make a really tiny piece of artwork, go ahead. Again, the industry will say you're silly for doing that, but I won't. I think it's really cool to enable people to do things that otherwise they wouldn't be able to do.
That would actually be fun to go to like a gallery and it's just like a wafer, or not a wafer, but even just like a chip up on a wall. It's just like everybody has to wheel around their own like magnifiers, in order to see anything.
Yep. And there actually is a long history of silicon designers putting silicon doodles in their chips.
Yeah, you got to fill that space with something. You're paying for it.
Yep. It'll be interesting to see if people with a little bit more artistic talent got in there and did some interesting things. There's a whole bunch of stuff you could probably do with like diffraction and stuff like this. I'm no expert, but it definitely feels like there's opportunities to do fun and interesting things there.
So first off, silly whiz is the word I was trying to remember. That's the thing that Matt always sings and or whispers. That's the learning tool for analog circuits. So 180 is where we're at currently.
Yep.
Global Foundries over in Singapore. I mean, does it mean you've had to be over there? Like, have you been able to go to the fab? How has that relationship worked? And like, what does it look like in terms of you working with them?
I don't need to be in Singapore myself, although I will be visiting there in a couple of weeks. The actual relationship is mostly just signing contracts and doing all that type of boring paperwork. I do that so that you guys pretty much don't have to. Other than that, there's actually not a lot to do here, which is also why it can be as cheap as it can be, right? Like, when you think about it, my project divides this by 40 slots. That's at maximum 40 customers that I have to deal with. At the moment, the kind of cadence we're looking at is once every 3 months. Dealing with 30 to 40 things once a quarter, is not that hard. The logistics are actually pretty easy from that size. And like the great thing about silicon is it's really small.
You're not scaling up a new factory or, shipping. You don't have to deal with like shipping and logistics of like, big truckloads of things.
Yeah,
huh?
Your 1,000 chips would probably easily fit in a normal envelope. Obviously I wouldn't be shipping in an envelope because, you want to protect them, but it's not a large amount of space, even though the number seems quite big.
Yeah, right.
The other reason is that I'm doing it in Singapore, is there's a bit more uncertainty at the moment with stuff happening in the US. And so if you're not in the US, having a group outside the US that you can work with, I think is quite useful. And, as an Australian, I'm technically outside the US from that point of view.
Right. You spend a lot of time in the US, but you are outside the US.
Yes. There's actually a couple of other services that have popped up after eFabless collapsed. That's kind of the nice thing about open source is that, everything eFabless had done was proprietary. It would have all died when investors had disagreements, right? But with, open source, there's a foundry in Europe called IHP that does a similar process to Skywater. It's a 130 nanometer process. You've got me in Singapore, and then there's a new group called Chip Foundry that is doing stuff with Skywater as well. And so now you've got 3 options to get open source silicon made, which is significantly better than one option we had previously. That also gives you options, right? Like if you need your chips manufactured, say in Europe, you now have an option. If you need it manufactured in Asia, you've got an option. I think that's an important part of building kind of resiliency in the ecosystem. It also, helps to have competition. It means if one group is doing something in a stupid way, the other groups can do it the right way. That kind of thing, I think, is also important about this.
You had mentioned, we keep kind of calling back to the eFabless stuff, and one thing you kind of call out on the crowd supply page too is about the IO ring and things like that. And so one thing I'm curious about is just like kind of you said you're trying to keep the cost low and stuff like that, but the supplementary services of like design checking and IO rings and things like it is it pared back from what people were doing on eFabless as well, like things that you have to bring themselves or checking they need to do, or is it just computer checking?
It's just computer checking on my side. We definitely will have templates that people can use if you don't want to design your own. I think the community has come a long way since when eFabless first started out. And I think there's also bit of a difference in that, like the Skywater, the I/O cells were extremely complicated. The I/O cells on GF180 MCU are a lot simpler. And so we also have tools like pad ring generators that now exist that kind of didn't exist, or at least weren't tested when eFabless first set out. So a pad ring is basically the I/O cells or the I/O pads. Pads are where, the wires are bonded to in wire bonding, and they go kind of around the edge of your chip. And so those affect how you package the chip. You kind of think of it as the footprint in the PCB world. A lot of that stuff has come a long way since 2020 when we first started doing all of this stuff. It made sense for eFabless to standardize a lot of that stuff when there was a lot more unknown and uncertainty there. And that does mean that they could offer, getting you back a PCB board with your chip mounted ready to go, which is something that I'm not offering, for example.
Got it. So they tied that into the packaging option then. Like the tiny tape-up board comes back with like one QFN mounted to a PCB, that sort of thing. But that's because it comes back from eFabless as a QFN, right?
Yep. That also drives the cost up and reduces the flexibility. And so that's definitely good for when there was a lot more unknowns. But since the world has kind of become more mature and a lot of the open source tools have become a lot more mature, I think that's less needed now. And optimizing more for cost, I think, is a strategy that I'm exploring. Chip Foundry, which is the US-based one, is going for a more all-inclusive service, is my understanding, which makes it a bit more expensive. Which kind of also makes sense because the base Skywater technology is also more expensive. The value adding of having that makes a lot of sense. And so this is also what's good about having multiple options is that we can explore which one makes the most sense, right? Maybe it will turn out that everybody uses the same template with my service and we want to bring packaging back in as part of the service in the future. I don't know. I've got lots of requests for Bear Die. We'll see if those people actually put their credit card into the system or not. That's always the big thing is people say plenty of things, but until they actually put their money where their mouth is, it's hard to know if that is actually a real thing.
That's product manager 101 right there, right? It's like, yeah, don't listen to the feedback until they plop the credit card down.
Yep. And so we'll see what happens. This is my attempt at doing this, but, I'm like anyone else. I'm making it up as I go along, and we'll see whether or not I've made the right predictions here. And I'm open to change as well, right? If this doesn't work the right way, we'll change it until it does.
Where do you usually refer people, just to kind of wrap it all up so that people are understanding where they should be going if they're hearing this next? First off, where do you refer people if they need some help with stuff? In terms of getting stuff off the ground, almost like design services around in this space. And then if they're doing it all themselves, then what are the next steps, that sort of thing?
I kind of have a thought that goes like this, if you've never done anything before, I think your best bet is starting with Tiny Tape-Out. As I said, Tiny Tape-Out is currently working on support for GF180 MCU. Once they've validated that, you'll even be able to move designs from Tiny Tape-Out directly to Wafer Space. That's not ready yet, but coming in the future. If you've done a design before and just want to start making your own chip, then I recommend either joining the Wafer Space Discord or the Fossey chat element. Either of those methods will get you into a community that has a whole bunch of people doing stuff in that space. There's also a number of companies that are offering commercial services if you want to pay somebody to help you do designs. People like Chipflow or My Brains are happy to offer basically paid support. Waferspace itself doesn't offer any paid support.
Did you say my brains?
Yes.
I need to get this chip idea out of my brains onto the silicon?
I, for a long time, called it MA Brains. but apparently it's my brains. They did a
it.
lot of work on the open source tooling, and in fact are behind a bunch of the stuff that was done to get the GF180 MCU PDK out there. And so they're very familiar with that. I definitely think we're in early stages, so there'll be a lot more as people do tape outs. I'm working with a guy called Leo who is doing a lot of the things like the examples and the pad ring. Those will be available shortly as well. As well, as you said, sign up for the crowd supply to be notified, because as the campaign goes along, we'll definitely be sending out updates with more information on examples. One thing we do have is that because there were 2 Google shuttles that had run previously, we do have at least 80 designs that have been previously manufactured using this technology.
And those all had to be open source too, right? Wasn't that a requirement of the free shuttle?
Those basically provide an example of what can be done on this technology, and we'll definitely work to highlight some of the coolest ones that you can use as inspiration. I'm slowly getting around to updating the website with that, and probably again by the time this is posted, there'll be some more stuff on the website in that area.
Yeah, that's great. I think that, like you say you can do anything to me, and it's just like, I'm like, I say, oh, okay, I'm going to do nothing, right? But if you start showing like examples, it's like, oh, I could modify this to be a little bit different there. You creating a new sensor or a new processing element around it, I could maybe use that in a different space. Like those kind of examples are super useful. And yeah, that's great. You continue to push the field forward, and I'm really appreciative of it. I'm not taking the jump myself, but hopefully someday in the future, I'll hold some silicon I designed in my hand, because like you said, it's increasingly accessible. I'm never a bleeding edge kind of person, but I'm right in the middle of the curve, and I feel like that curve is catching up to me real fast.
Yeah, and like as I said, it's $200 and 2 hours on the weekend to like do your first design. And like as I said, don't worry about the fact that you don't know what you want to do or any of these type of things. Just jump in and work through the examples. If all you do is submit a thing that, does the example output, which I think is like outputs your name on the LED, $200, I'm sure as I was saying, like that's a piece of Lego, it's not an expensive Lego kit. It's more of the lower end Lego kit, right?
That's a cocktail party story right there too. I mean, you bring this thing, of course you bring your circuit boards with you to a cocktail party, and then you're like, hey, look, I designed this.
Something to keep on your desk, right? Like that you can show off. I think somebody like you, 2 hours is perfectly reasonable to get that Hello World out there. It's not a thing like Matt Venn teaches a course quite frequently, a live course, and most people are able to submit something to be manufactured by the end of that course. And the biggest blocker I've seen is people just going, the thing I'm doing is, trivial and these type of things. Everything somebody does at the beginning is trivial. It doesn't matter that, like, that's how you learn, right? You do something trivial and you keep doing it until somebody turns around and go, hey, wait, that's no longer trivial, right? Like, I'll challenge you that by the time I'm on the next amp hour, you've done some of your own silicon.
That's fair. That's fair, man. I like it. Challenge accepted.
Great.
Especially because I'm in charge of scheduling. You're like, Tim, you can't come back yet. I need to spend 2 hours on the weekend.
Yep.
All right. Well, Tim, thank you once again for being here. Wafer.space to check out Tim's latest project. Check it out. It'll take you to Crowd Supply to sign up if you're interested. Looking forward to talking to you next time and having a design in hand, of course, because I have to.
Cool.